So Panayiotis is going to present his work entitled Tailoring 3D Mapping Framework for Field Robotics.
So, hello everyone. Can you see my screen?
We can see your screen.
Right. All right. So today I'm going to talk about some tests that we did with my colleagues at the Ingeniarius about mapping frameworks for outdoor robots. So in this sense, we did some preliminary research to find out which would be a suitable mapping framework for outdoors. And we compared basically what was out there at that point in time, and we gathered it and prepared the poster. So what's the scope here? The scope is providing the ability to the robot that works outdoors in applications such as agriculture and forestry to map its surroundings. Mapping facilitates the localization process of the robot, which is the simple answer to the question of where I am. But also assists it over time by registering landmarks. This process is known as SLAM, by the way. So the objective is basically of this work to present the challenges of mapping in outdoor environments and present the overview of existing frameworks. We have performed in this work a parametric study between two of the most suitable frameworks that we found out experimentally. In a simulation environment and as well as with real world experiments. And those frameworks are OctopMap and RTAPMap. As metrics, we use the percentage of the matching occupancy grid cells of ground truth maps, which in simulation was acquired in the Gazebo framework. And also in the real world experiments, it was performed with some filtering of the top view of the area. So what are the challenges for outdoor robotic mapping? Well, people that have worked in the domain know that it's unstructured and it's highly dynamic. It's full of disturbances, name it, weather conditions, illumination constraints. Of course, in order to have a map, as we said, you have to have good localization, which most multi-sensor fusion architectures usually embed GPS, which in forestry environments might not be always available. And this affects as well the mapping process because you need to have a really reliable and robust odometry to create your map. Another domain that a lot of work is focused on is noise filtration, which basically we need to remove the unwanted effects from the environment and have a cleaner map. A third one is the high dimensionality of the entity. What I mean by entity is basically the data representation problem. You can represent the map as a 2D occupancy grid. You can create it and represent it as a 3D point cloud. But with each one, there are forthcomings, which means that you will meet different kind of problems based on the complexity. Another interesting parameter, let's say, of the whole process is loop closure, which is basically correcting your trajectory over time based on the recorded landmarks. So in common sense, it's if you've seen in visual SLAM methods, if you've seen a scene or an image before, you can calibrate your error over time and create a more robust map. The other two parameters are updatability and shareability. Updatability in the sense of you record your trajectory in an outdoor environment, you map it, you store it, and you can update it later on from where you took off. And shareability is a useful feature for using it in multi-robot systems, but as well as cooperative frameworks. in the sense that you can share the map with other robots or even humans in the future. So regarding the resources and the metrics, as I said, the arrow represents the number of cells that do not correspond to the ground truth. And the accuracy is the number of cells that correspond to the ground truth, divided by the total number of cells, which in our case we found for the simulation environment was that number. So let's talk about tech for the experiment. So in this experiment, we used common hardware for the simulation and the setups. This was a Intel Core i7 CPU, 16 gigabytes of RAM, and an NVIDIA Quadro GPU. And for storage, for speed, we used 256 gigabyte SSD. The two setups consist of the agricultural simulation and the Husky robot from ClearPath Robotics, which is a commonly available framework. And for the real-world experiments, we've used the robots developed by Ingeniarius, which is the Vineward robot and the Ranger robot for outdoor applications. So for the preliminary work that we conducted for this study, we identified 6 frameworks at the time. One was G-mapping due to its performance and its probabilistic approach for 2D mapping occupancy grids mainly. Elevation map, traversability map, cartographer, Octomap, and RTAP map. So we defined some features here to classify which method basically has more to offer. And by observing, the most complete ones are the 2 last ones, which are Octomap and RTAP map. Of course, this comparison is based on mapping only. So the other frameworks are used in specific, let's say, applications of the whole mapping process and could aid navigation. So we were seeking out in this work which would be the ideal mapping framework for outdoors in our use cases. So let's run to the results. So in this sense, in the simulation, we set up a simulation in Gazebo. We have in figure 3A, the ground truth, which is basically what you see in this area here with the solar panels. So we started from indoors and went towards outdoors to try to map this. And we started as ground truth. As you can see, the amount of cells that were erroneous were more with the RTAP map framework and less with Octomap. So Octomap performed better in this sense. In terms of accuracy, well, they're quite similar, but again, Octomap being the best one by a short amount. A thing to note here is that although Octomap is slightly it is slightly how can I say this? It's slightly more efficient in storing the map in a compressed format, and it uses octrees internally to represent the data. RTAP map has similar functionality, but instead of compressing it, it uses its own database. So after achieving this initial test beds to identify the parameters of the 2 processes, which are many, we decided to move on to real-world experiments and see how representative would be the mapping process with the robots. So in regarding the CPU usage, Octomap on average was using 60% of the resources and 90% of the memory that was available to the robot, only for mapping. So I need to clarify here that this was only used for mapping. And of course, mapping larger areas might be a problem between the frameworks, which we have identified within the paper, but there was not quite a lot of space here to present. But the results showed in this sense that Octomap had less accuracy in the overall large area that was mapped, as you can see beneath in figure 4, than ArtaMap. So ArtaMap in comparison was using a bit higher CPU, but it was overall consistent, which means that the drag would not deviate that much and would stick to 73.6%. Again, ArtaMap would use a bit more memory, about 3% of the memory. So this is a downside if you plan to use ArtaMap in a resource-constrained robot. That means that if your robot is small enough and doesn't have enough power supplies, there's a high chance that it cannot be usable for a long period of time. In terms of error, ArtaMap had way less error, about 6,141 misclassified cells compared to the ground truth. And in terms of accuracy, it was at 0.99, which is quite high for mapping. So in order to conclude, both frameworks come with parameterizable filters, ground segmentation, and can map large areas. But we found out that ArtaMap's database requires more memory than Octomap. Both have strategies to solve the correspondence problem, but ArtaMap uses feature strategies and configurations that apply a loop closure detection, which does not happen in Octomap. Both address and map dynamic obstacles, although Octomap struggles more to update the map when a large dynamic obstacles become absent, such as humans and moving objects, which in our case we saw in some of the recorded ROS bags that some animals, such as cats, would not be captured and will be identified as an object. On the other hand, we're praising ArtaMap, but Octomap's generated octrees are lightweight and can be easily shared between robots, which could lead to a decentralized solution. ArtaMap provides a better parameterization of the map, which gives us more flexibility in tuning the odometry features, because you have many odometry types that you can identify, and this I have to note that ArtaMap is like more than 10 years effort in Visual SLAM, so it constantly improves and integrates more sensors such as GPS and IMU. Let's say.
Can you conclude, Anios?
Yes, sir. Yes, sir. So in order to conclude, ArtaMap is a SLAM approach that shows better performance than Octomap, and this work serves as a guide for parameter tuning of the frameworks for outdoor applications. Due to the vast parameters involved, people can have a look at the paper that we will have available after this event. So this is it. Thank you.
So, are there any questions from the people online? No? Okay, so I have one question. So, in the case that you have it here, you compare Octomap with the ArtaMap, but in regards with the power, CPU power occupied, you still need to use some CPU power for localization while using Octomap. And did you assess while using Octomap the amount of resources that had to be allocated for localization?
No, this wasn't included in this study.
It's already included in the RTAB map and
Yes. In RTAP it's a visual SLAM method. Octomap is a mapping framework.
And one other question is regarding to the map construction. You always assume that the robot is where it is supposed to be. So there's no error included in the positioning. Or is
in this test, yes, we didn't test the robot kidnapping problem.
Okay.
Although from my experience, RTAP can mitigate for that.
Okay. Okay, so let's move on to this next presentation, again with Panagiotis, the comparative study of mobile robot positioning using 5G and R. And I must stress that the presentation is 6 minutes plus 4 questions. Okay.
All right. Thank you. Can you see my screen again?
Yeah, you can.
All right. So in the study, we are trying to use the 5G new radio, which is a communication, which is the new generation of communications, widely available in rural and urban areas.
Sharing the same PowerPoint, the same presentation. Are you going to show us some other presentation, or is it this one?
This is the presentation. Because it was the poster thing.
Okay.
It's okay?
Go on.
All right. So the objective here is to estimate the position of the mobile robot moving in a rural area based on 5G radio signals. We used 3 methods to optimize the position because it's a nonlinear optimization problem. We use the hyperbola crossing points, the particle swarm optimization, and the genetic algorithm. We tested 3 different setups with a variable number of GNBs. GNBs are the base stations where the telecommunication antennas are placed. Our metrics are the mean execution time and the Euclidean distance between the ground truth and the estimated trajectories. So,
Panagiotis, you're sharing the poster from the previous paper.
Sorry. Okay. So, let me correct that.
No, we okay. Can you share again? Yeah.
Okay.
Okay. Now it's correct.
All right. So let's go to the methodology. So what we're trying to achieve here is have the robot carrying the UE, which in telecommunications, UE is the user equipment, which in a sense it's similar to the modem, and try to track its position over time through the base stations. The techniques used since the start of cellular networks to track in emergency scenarios was trilateration, or also known as multilateration. As I said, it's a nonlinear optimization problem, which is defined by this equation. And the ranges for the problem are computed by the speed of light and the sampling rate of the signal. We're doing this in 2D because we wanted to have a method to access similar to GPS, the X and Y coordinates for the state estimation. And also evaluate it initially because we're talking this is preliminary work. So a few words about 5G new radio. The good thing about the 5G new radio is that compared to 4G LTE, you have now position reference signals, which were developed as a separate signal that utilizes the downlink scheme with a carrier frequency of at the gigahertz level. we've chosen for the simple case the modulation scheme to be QPSK. And for the transmission, we are using VOFDM, which means orthogonal frequency division multiplexing modulation. Some might say that, yeah, a lot of problems might be here. We were addressing the hearability problem, which is the problem of interference from distant GNBs on the radio signal. But then this is avoided basically by transmitting a PRS signal in a separate slot. So as I said, we have three methods: the PSO, which was configured with a population size of 200 and the iterations were set to 1000. The GA with a population size of 50 and the generations were set to 200. The elite count for the GA was set to 0.05% of the population. And the HCP performs time difference of arrival with all the GMBs and then chooses the closest 5 for position estimation. In figure 2, you can see the ground truth position that was recorded with the robot that Azim will show you later. And let's talk about the results. So in regards to the 3 setups, in the first setup with 5 GNBs, as you can see in figure 3A, the base stations are kilometers apart, and this is the ground truth trajectory as I showed in the previous image. The HCP was more accurate than the other 2 optimizers, but it took 1.5 seconds to compute it, which in the sense, if you're trying to get your position estimation, is a bit slow. But the other 2 optimizers beat it as it was faster, and they have similar times. In terms of accuracy, because this was the initial configuration and setup, they're slightly worse than HCP. And this changes in the second setup, where the GA has the fastest mean execution time and the smallest Euclidean distance, which in 2D is the distance of your ground truth with the estimated trajectory. In the third setup, again, the GA was the better performing. Although the PSO had similar accuracy, it couldn't cope with the execution time per measurement. And these measurements were performed, these position estimation measurements were obtained for every 100 ground truth intervals. So in order to finalize, these preliminary results show that it can be used for positioning of robots with optimization based on GA. The accuracy can improve with representative channel estimation modeling from real data. This means taking into account the interference from trees, buildings, diffractions, and reflections, which is future work. And the goal of this overall research during my PhD studies would be to develop a robust 5GNR SLAM method for multi-robot systems and complement the localization and GPS-denied environments. And that is all.
Okay, so thank you very much, Panagiotis, and we'll move to the next one, which is myself. So I will share my screen now. Okay, thank you, Panagiotis.
It was better than it was. It's like I told my fast. Better than.
Do you have? Did you don't? No.
And I bought too much and I stored it. And I said, this is good, I best invest. It's like that 4x4 by 2 feet, which I paid $36, now $100. I could sell that in the market for profit. It's like, not like what was the price of cedar is not the price of iron. It's
Okay, so I'm going to start.
We live in a golden era, and now it's like everywhere comes from. but I think it's going to be.
Okay, so my name is Luis Condovento, and I'm going to present a work from my team in Coimbra, and what this work is entitled "Comparative Evaluation of Mobile Platforms for Non-Structured Environment Performance Requires Identification for Forest Clearing Applications." And it's a big title for a simple thing. So we wanted to identify platforms that could be retrofitted in order to be used in forest clearing, and to check if this platform should if she is already available and it's adaptable. Okay. So what's the context? Context is that we have a lot of fires that are arise from power lines that touch branches of trees, or that some carbon that is accumulated on power lines falls and ignites and starts a fire. And in order to perform some forest clearing where the power lines are installed, it is necessary to automate a bunch of equipment, and the one that is more suitable, it's the main cause of this work. Okay, so in forest clearing, we want to assess all of the platforms and check the platforms in terms of the energy source, the motion systems, sensors, actuators, and so on. Common solutions that exist nowadays are more or less clustered in three types: remotely operated, conventional tractors which are instrumented, and a fair good amount of prototype type tractors that are currently available for sale, but they are state of the art. Okay, so we evaluated all platforms in terms of their locomotion, steering, gross weight, and the ones that made a stand were from Milrem Multiscope, Architect, Energreen. And these ones, they were interesting in their features regarding mobility. Regarding power supply, the main key KPIs that we used for assessment was the propulsion system, operational range, battery, charging time, and in this case, Monarch, which is a prototype, was the one that had the best evaluation. Covaco, they also had a good evaluation, but they were penalized because of their operational range. Okay. In terms of control, we classified the control in several degrees: manual, assisted, supervised. In this case, the Volvo, which is a tractor used for agriculture, had the highest ranking. It is more or less fully automated for crop harvesting, and that's why it has such a high rating. Perception, regarding perception, the or platforms that have sensors for specific purposes, namely for operation of
Yeah, so I got the question.
for positioning.
Actually,
These were more
I thought it worked out pretty well.
prized, namely Monarch and
Everybody else.
regarding communications. Regarding communications, external communications might be CAN bus, Isobus.
Basically, we introduce ourselves.
Also, one of the KPIs using this metric. And external communications are more regarding G communication, LTE, etc.
Sounds good. Where I just sit up there.
Yeah, we'll sit up there.
Not able to turn on.
Are you presenting while the other mics are on? There's a mic array going on in here right now. So they're hearing George more than they're hearing you if
Yeah,
you're
so
presenting.
how do I turn off those microphones?
It's not that big of a crowd.
Just your left. I don't know what the right answer is. I didn't know he was just gonna be presenting all by himself up here in silence, so it's not the way to do it.
So.
Yeah, probably. Like the microphone.
Okay, is it okay now?
I mean, it depends on what microphone
Yeah,
you
okay.
selected. Are you
Okay.
using the local
Okay,
microphone?
Right now, he switched.
All right, but still, they're hearing him
okay,
pretty well.
so.
It is better now.
Yeah, so regarding tools and attachments, we were interested in evaluating the position of the mulcher, the power grade, so how fast could it clean, compliance with standards, and Kubota was the one who had the best results. Okay, so we assembled all of those metrics in the table and also made an assessment of how was the availability, because some of these platforms aren't ready available for purchase, although they are more prototypes. So we made that evaluation as well about availability and price, and that led us to the overall results. And the overall results is published in the website, in a GitHub website, so you can assess and you can see all metrics in detail and their evaluation per platform. Okay, so that's it. We were in a hurry to finish this early on so that we could move to the next panel session. So I don't think that we have time for a question. We have time for a question. If there's someone who wants to ask something, please write in the chat.
My question, may I put the question?
Yeah. Go for it.
Okay. So my question was about the power. These machines are mainly diesel powered, or do you have here electric?
Yeah, mainly they are diesel powered, but there are some, well, energy wise speaking, there are some platforms that are becoming available. Nevertheless, most of them are not in production. So you have one example as Bobcat, which was bought by Dawson, as Mikael told earlier. They're selling version with electrical drive. As another one is Kovaco, but nevertheless, their availability is in they're not they're not pretty ready available, and the one which, in my opinion, is more easy to purchase, which is Kubota. Their batteries are lead acid, which goes against the what we think that it's interesting, which is to have a more sustainable environment without lead. Okay.
Okay. Thank you
Very much. Bye.
Bye-bye.